welcome back to TensorFlow. Today we are going to solve another Leetcode problem on arrays topic, which is rainwater, trapping rainwater. So this is going to be our last problem on arrays topic. After this, we will start a new topic, which is strings, and we will solve some of strings problem on Leetcode. So now let's get started and see that what the problem statement is and how to solve it. So this is problem number 42, trapping rainwater. This problem is tagged as hard. So now let's read the problem and easily understand that how to solve this problem. So the problem statement is, given n non-negative integers representing an elevation map where the width of each bar is 1. Compute how much water it can trap after raining. So we have given an integer array. Now what this integer array is representing. So let me open my notebook. So yeah, this is the integer array that we have given, and this is the graph or the bar chart of that array. So if you will see here, the first element of the array is 0. So what these elements are representing? So these elements are representing the height of blocks, which means the first block has height of 0 unit, and the second block, which is this. So this is representing the block of 1 unit. These are two blocks, so the height of these blocks is 2. The height of this block is 1, so here is 1. So now what we have to calculate, what we have to find in this question. So we have to find that how much water can be trapped between these buildings or these blocks. So if you will see here, there is 1 unit water, 2 unit, 3 unit, 5 unit, 4 unit, 5 unit, and 6 unit. So total 6 unit water is trapped between these blocks, and we have to calculate the amount of water which is trapped between these buildings. So if you will see here, the answer is 6, because this is the amount of water that is trapped between these buildings. Now the question is how we can solve this question, how to measure the amount of water that can be trapped between these buildings. So before answering that question, I have another question, that what is the condition of water getting trapped between these buildings. So if you will see here, why water is trapped here, the answer is the water is trapped here because there is one higher building on the left side of this block and one higher building on the right side of this block, and the highest building is this. So the condition for water to get trapped between these buildings is there should be a higher building on the left side, and there is should be a higher building on the right side. We have to satisfy this condition for trapping the water. Now how to calculate that how much amount of water it will trap, so we will see that thing later, but first let's satisfy this condition of trapping the water. So what we will do is we will create two arrays, left and right. In left array we will store the higher building on the left side, and in right array we will store the higher buildings on the right side. So how to do this? Let's see how to fill this array. So we will start from the left side, which is this. So the first element is 0. So there is no higher building on the left side of this element, so we will store the current height of the building. So the current height of building is 0. Now let's go to the second element. The second element is 1. So the height of this building is 1. So is there any higher building on the left side of this element? No, there is no higher building than this element on the left side. So we will store the current height, which is 1. Now we will check for this building. So is there any higher building on the left side? Yes, there is one higher building on the left side, which is of height 1. So we will store 1 here. Why we are storing 1 here? Because there is one higher building on the left side of this element and the height of that building is 1. So we are storing 1 here. Now we will check for this. So if you will see here, there is no higher building on the left side which is higher than this building, this current building. So we will store the height of current building, which is 2. Now we will calculate same for this. So is there any higher building on the left side? Yes, of height 2. Then we will check for this. So is there any higher building on the left side? We have to check the highest building on the left side. So the highest building on the left side is this, which is 2, of height 2. So we will store 2 here. We will check for this. So is there any higher building on the left side? Yes, this is 2. Then we will check for this building. So is there any higher building on the left side which is higher than this building? No, there is no higher building on the left side which is of 3 height. So we will store 3 here. Now we will check for this. So is there any higher building? Yes, 3. So we will store 3 here. Then for this we will store 3. Then for this we will store 3 again, and for this we will store 3 again. So now we have filled our left array. Now let's fill the right array same as this. So what we have to fill in right array, we have to check that is there any higher building on the right side of every building or not, and we will start this from the right side. So we will store this element first. We will assume that this is the highest building on the right side. So this is of height 1. So is there higher building On the right side of this building, no, there is no higher building, so we will store current height of 1. Same for this, is there any higher building on the right side of this? So no, there is no higher building on the right side of this, so we will store the height of current building, which is 2. We will check for this, so we have one higher building of 2 height. And then we will check for this, is there any higher building on the right side? No, there is no higher building on the right side, so we will store 2 here. uh, 2 here, the height of current building. Then we will check again for this building, is there any higher building on the right side of this? So no, there is no higher building than this, so we will store 3 here. Then we will check for this. So there is again 3, so we will store 3 here. Then for this we will store 3. Then for this we will store 3. Then for this we will store 3, because there is no higher building on the right side of these elements which is higher than 3. And then for this we will store 3 again. And for this we will store 3 again. And for this we will store 3 again. Now we have satisfied the condition for storing the water, for trapping the water. Now we have to calculate, as a next step, we have to calculate that how much water is trapped between these buildings. So for that we have to check, if you will see here on this side. So if you will see here, here, if you will see here, 1 unit water is trapped. So the condition for the amount of water getting trapped is, if you will check this, if the water is like this here, if water is filled till here, so it will flow, it will from here. So the water can only be trapped till the height of minimum building. Which means if you will take this and this building, let me erase this first, and after that, so if you will check here, the amount of water which is trapped here is 1. uh, Let me take green pen. So the amount of water which is trapped here is 1. So 1 unit water is trapped here. So the amount of water that can be trapped between two blocks is of minimum height, which means if you will fill water till here, if you will fill water till the maximum height building, so this water will flow away. So the amount of water that can be filled between two blocks is equal to the height of the minimum height building on the left side, and it can only store water of minimum height building. So the condition is we have to check for the minimum height building, which means if you will see here, let me give you this example, this will clear all the concepts. So if you will see here, the amount of water which is trapped between this and this building is 1 unit. So if you will check on the left side, there is one building of 2 unit height, and on the right side, which is the higher building on the right side, this building is higher on the right side. So the height of this building is 3 unit. So it can only trap water which is equal to the height of minimum building. So this is the minimum building. Now here the water which is trapped is 1 unit. So we have to subtract this unit from here, the height of current building. If you are not understanding this, when I will write code, I will dry run the code, then you will understand that what I am saying. So try to understand this point first, because the amount of water that can be trapped between these two buildings is equal to the minimum amount height of the building, which is this, the minimum height 2, and the maximum height is this, which is 3 unit, and the minimum height is 2 unit. So the amount of water that can be trapped will be equal to this, but there is one more block under this water, so we have to subtract this block from this height, then only we can get the amount of water which is 1 unit. So we have to do this process for every block. We have to do this process for every block of this graph. Then we will find the amount of water that is trapped between these buildings. So let me dry run this code and show you how to solve this. So if you will check for the first building, so what is the minimum height of the building on the left side, which is 0, and what is the maximum height of on the right side? Minimum height on the right side, sorry, what is the minimum height for first element? We are checking it for first element, that how much water the first element can store, which is this, it is storing 0 unit water. So we will check for this. So if you will take this element, the maximum height on of the building is 0 on the left side, the maximum height on the right side is 3. So we have to take minimum of these two. Why minimum of these two? Because the water can be trapped, which the amount of water which will get trapped between two buildings is equal to the minimum height of the building. So we have to take the minimum height of the building. Now the minimum height is 0, so we have to take 0, and we will subtract from the current height, which is also 0. So the answer is 0 here. So on the first place we have 0 unit of water. If you will check for this, let me copy this image, move this image from here to here, and let's check for this block. So let's check for this block. this block. So for this block, this is 0th element, this is first element, and this is second element. So we have formula for finding the amount of water. So amount of water is equal to the the minimum of left side of the building, highest building on the left side, and highest building on the right side, and we will subtract this from the current height of the building. We will subtract this from the current height of the building. So for the third element, we have height of 1 unit, highest is 1 unit, so minimum of 1 is minimum of 1, and on the right side what we have 0 1 2. So on the right side we have minimum height of 3, so we will store 3 here, and we are checking for this block, we are checking for this block. So we have left side we have one height building, which is 1 unit building, and on the right side what is the highest building, which is this building, which is of height 3. So we have 3 here. So the minimum of 1 and 3 is 1, and now we have to subtract the current height from the building. So what is the current height of the building? It is 0. So the amount of water which is trapped between these two buildings is 1. So as you can see here, this is 1. So this is the approach for solving this problem. Now let's write the code for this problem, and after that I will dry run the code and show you how this approach is working. So as our first step, what we have to do, if you will see here, we have to initialize two arrays, two empty arrays, left and right, and the length of those arrays will be equal to the length of original array. So the first thing that we have to do is, step 1 is creating two empty arrays, left and right. So we have created two arrays, and the length of those arrays will be equal to the length of the input array. So we will store length of input array in this variable called NHEIGST. So the length of input array will be equal to, sorry, the length of left and right array will be equal to the length of input array. So we have created two empty arrays with the height with the length of n element. Now the second step is we have to fill our left array. So what we have to fill in this left array is we have to check for every element, for every input element, for this element we have to check that is there any higher building on the left side or not. If there is no higher building on the left side, then we will store the current height. So which means we have to start a loop for I in, so we will assume that the first element, the first building on the left side is highest building. So we will assume this. So the first element of this array will be equal to the HEIGST, height of 0, which means we are considering this element or this block as the highest block of all array. Now we have to start a loop for I in range of 1 to n. So we are starting loop from here. We are starting loop from here, and we have to store and we have to fill this array. Like we will check, we will take this element which is 0, and we will take this element which is 1, and we will check that what is the maximum between these two. So the maximum is 1, so we will store 1 here. Why? Because this will be the highest building. We will check maximum between both, and the maximum will be the higher building on the left side. So we will take maximum of L I minus 1 and height HEIGST, height of I, which means what we are checking here, we are comparing two corresponding elements. We are comparing these two. So we will take this and this element, these two elements, and we will check which is maximum between these. So 1 is maximum, so we will store 1 on the first element of the array. So we will fill like this, we will fill our left array. Now it's time to fill our right array. So we will start our right array from the right side of this diagram. We had started this array, which is this array. So we have started this array from the right side of the building. Let me use green pen. So we have started this right array from the right side of the graph. So what we have done is we have considered that the rightmost element of the array, which is this element 1, we have considered this element as the highest building on the right side. So we will do same here. So we will store n minus 1. On the n minus 1 place, we will store HEIGST, height n minus 1. So we are storing this element on the right side of the array. Last element of the right array, we have stored the last element of the height, which is 1. Now we will start another loop for I in range of n minus 2. Why I am writing n minus 2 here, I will explain it to you later. So minus 1, minus 1. So now I have started this from n minus 2. Why I have started this from n minus 2? Because we have already stored this element in our right array. We have already stored this element in our right array. Now we will start comparing this element with this element on the right side, and then we will compare these two elements on the right side, and then so on. So how we will do that? We will store in the right side. So for right side we will take maximum of right I plus 1 and height I, Height. So we are taking maximum of these two. First we will take this element and compare it with this element. Then we will compare this element with this element, and we will choose the maximum number between these two. So we are storing that maximum in our right element. So we have filled our right array and our left array. So in our left array we have stored all the higher building on the left side. If you will see here, we have stored here in this array, left array, we have stored all the higher building on the left side of the array, and in this right array we have stored all the higher building on the right side of the array, which was our condition for trapping the water. So now we have satisfied the condition for trapping the water. Now the next step is to calculate that how much water will be trapped between these two buildings. So for that we have our formula, which is this. So for the formula is, we will take minimum height building between two blocks. We will take minimum height building and we will subtract it from the current height. Then we will get our the amount of water that is trapped between those two buildings. So for I in range of n, we will start this loop and we will iterate over this array, and for every element we will check a higher building on the left side and right side. So what we will do is, we will let's initialize one answer. So let's assume that in first, when the iteration is started, the answer is 0. We will initialize our answer pointer, our answer variable from 0, and then we will add every time plus equal to, we will every time add the amount of water which is trapped between every building. So first we will check for this building. First we will check for this. So how we will check for this? We will take the first element of left array and the first element of the right array, and we will check that what is minimum between these two. So the minimum is 0 here, and then we will subtract it from the current height of the building, which is 0. Then we will get the amount of water trapped on the first block. So in this block, the amount of water which is trapped is 0. So by this we will find the amount of water. So minimum of left array and right array, minimum of left array and right array. After that we will subtract it from the current height of the building. So HEIGHT and current height of the building. And after that we will store every unit of water in this answer variable, and then we will return the answer variable. So let's check if the code is working or not, and it is passing every test case or not. So yeah, our code is working perfectly. Now let's submit it, and let me give you a quick overview of this solution. So let me copy this image from here to here. So if you will see here, we copy this image. Okay, so let me copy new image from this. Sorry. So I have copied my left array and my right array. So let me give you a quick overview of this problem again, and I will explain it very clearly this time. So if you will see here, what this left array is representing. This left array is representing that is there any higher building on the left side of every element or not, and this right array is representing is there higher building on the right side of every element of the array or not. So what this 0 is representing, that there is no higher building on the left side of this element, and the highest building is 0. And for this element we have the same condition. So for this element we have the condition which is, we have highest building of 1 unit on the left side, and same for right, we have this condition that the most highest building on the right side is 3, and then we have 3 3 3, and if you will check for this element, the highest building on the right side is 1. So now we have our left array and our right array. We have satisfied this condition. This whole condition is for trapping the water. This is not for amount of water getting trapped. This is just for trapping the water. Now we have to calculate that how much amount of water will be trapped between these buildings. So for that condition, we have to calculate, we have to make a new formula. So if you will check for this building, I am giving the example of this building because this is the most common case of this problem. So if you will check here, what is the amount of water is stored on this place? So it is 1 unit. 1 unit water is trapped on this building. So how we will calculate this, that the amount of water is trapped between this building? So for this building we will check, is there any higher building on the left side? Yes, there is a higher building on the left side. Is there any higher building on the right side? Yes, there is a higher building on the right side. So what is the height of the higher building on the right side? It is 3. higher building on the left side of 2 unit. Now we have to take minimum of these two. Why minimum of these two? So if you will see, imagine that this is the bucket and the one end of the bucket is longer than the other. So if you will store water till here, the water will not flow outside of the bucket, but if you will try to store water here, it will flow from here. So this is the common sense. We just have to take the height of minimum side. So the minimum side is 2 here. Now we have to subtract it from the current height, which means if you have this bucket and one side is higher, but till here the bucket is filled with the blocks, so the water will be only this is the amount of water that will be trapped. So we have to subtract it from this height. So now we are doing the same thing here. We are taking the minimum of 2 buildings and we are subtracting it from the current building. So we got our formula for amount of water, which is minimum of 2 buildings of left side and right side. We will take minimum of left and right for current building and we will subtract it from the height of current building. That's the same thing that we are doing here. So now let me quickly summarize this code for you. So let me zoom in. So we are starting a empty variable. In starting, we are assuming that the amount of water that is trapped between buildings is 0. We are assuming this case. Now we are taking the length of our integer array and we are initializing 2 pointers, 2 arrays, left and right, same length of height. Why same length of height? Because we don't want to spend extra memory on creating a longer array. So we are taking this exact height of input array. So we are taking 2 empty array of n size. Then we are filling the first element of left array equal to the first element of input array. Why we are doing this? So let me give you a visualization. So we are doing this because if you will see here, we are assuming that this is the highest building on the left side. The first building is the highest building on the left side. So we are assuming this here. And then we are starting a for loop and then we are storing the higher building on the left side, which is maximum of previous building, which is 0, and the current height of the building, which is 1. So what is the maximum between these two? Which is 1. So we will store 1 on the first element. On 0th index, we are storing 0. On the first index, we are storing 1. And then this loop will continue and store all the maximum building of left side in this array. Then we will start our right array. So in the end of right array, we are starting right array from the right side, from this side. So we start filling this array from the right side. So we will assume that the last input or the last element of this input array is highest building on the right side, because there is no higher building than this on the right side. So we are assuming this here and we are storing the last element of input array in the last element of the right array, which is empty. Then we are starting a loop. We are starting loop from n-2 because we have to compare from this element. We are already assumed that this is the highest building, so we have to start from here. That's why we are starting from n-2 here. Then we will subtract every time. So we have to go here, 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 and here. So we will subtract -1 from every pointer, and this loop will run and it will fill this right array. So we are storing maximum between the current height and the previous height. Now we will start another loop. This loop is for calculating the amount of water that will be trapped between 2 buildings. So for that, we have already calculated the formula, which is minimum of left and right, and we will subtract the current height of the building. So we are doing the same thing here. Answer equal to answer plus every time we are adding this thing in the answer. So which is 0 plus the minimum height of left and right building. We are choosing the minimum height between left and right building and we are subtracting it from the current height. After that, we will get our answer. Then we will return this answer and we have passed every test case. So this was the problem, guys. Let me run this again. So yeah, this code is working perfectly. If you haven't understand it yet, try to dry run this code by yourself on the notebook and try to visualize these two things. Take this graph as it is, take this graph and try to fill this left array by yourself and this right array by yourself. After that, calculate this for 2-3 elements and then you will get that what is the solution and how this approach is working. So that's it.